So we're going to divide polynomials now, and we're going to do it in much the same way that you divided numbers in middle school. So let's throw it back. If I want to divide 7,654 by 6 through long division, you do one digit at a time, right? We ask ourselves, 6 fits into 7 only once, and to find the remainder, we go 6 times 1 is 6, remainder is 1, then we bring down the next term. Now we have this new division to do. How many times does 6 fit into 16? Twice. So we put the answer up top. Now we want to find the remainder again, so 6 times 2 is 12. My remainder is 4. Bring down the next term, and so on. Continuing in this way, we find our answer, the quotient, and we also end up with a remainder. So remember, the thing that you're dividing by is called the divisor. The thing being divided is the dividend. The answer is the quotient, and any leftover amount is the remainder. So if we want to get back to the original, we would do 6 times our answer plus the remainder would take us back to this. You can confirm that for yourself. So we're going to do the exact same thing, but with polynomials. The process is identical. So say I want to divide 3x cubed minus 5x squared minus 7x minus 1 by x minus 3. So I set up my long division. The dividend, the thing being divided, goes in there. The divisor goes in there. My answer will be my quotient, and I'll probably get a remainder. So we start in much the same way. We look at the first term over here and the first term in there. Don't worry about the second term, it'll take care of itself. What do I need to multiply x by to get 3x cubed? Well, 3 for sure, but to get from x to x cubed, I also need an x squared. So to get from this term to this term, I multiply by 3x squared. Notice I've lined up the powers. That'll make it easier for you, and we'll keep it nice and neat. Once you've found the answer to that, we multiply to find a remainder. Now this second term matters. So now this term we found times these two terms gives us 3x cubed minus 9x squared. And just as before, we now have to subtract. If you've got the right term above, these first ones will cancel. 3x cubed minus 3x cubed is 0. These won't necessarily. Negative 5x squared minus negative 9x squared is really plus, so we get 4x squared. Bring down the next term, just like we did with numbers. Now you want to fit just the first term into this first term. Second terms take care of themselves. So to get from this term to this term, I have to multiply by 4 and by x. So 4x goes up there. And again, multiply to find the remainder. Here's where my second term matters. 4x times x is 4x squared, and 4x times negative 3 is negative 12x. Now subtract to find the remainder. Once again, if you've done it correctly, these will always cancel. 4x squared minus 4x squared, 0. Negative 7x, this turns into a plus 12x, is 5x. Bring down the next term, and finally, fit x into 5x, that's just times 5. Answer goes up top, and now multiply to find the remainder. 5 times x is 5x, 5 times negative 3 is negative 15, and we are almost done. These cancel, and negative 1 take away negative 15 plus 15 is 14. So just as before, we've got our quotient, the answer, and a remainder. If we wanted to use these things to go back to the original, we would say that this multiplied by this plus this extra bit would give us this again. The divisor times the quotient plus the remainder gives you what you started with, the dividend. Now that might seem really tedious and long. So if it is, you might want to try synthetic division, where we get to kind of ignore the x's. So here's that thing I started with, 3x cubed minus 5x squared minus 7x minus 1, the dividend. And again, we're dividing it by x minus 3. So the nice thing about synthetic division is the x's just go away, and we're going to just work with the coefficients. This divisor, x minus 3, the 0 that goes with it, if I were to solve this factor, it would be x equals 3. 3 makes this 0. So we're going to work with 3, and we're going to work with the coefficients on the dividend. So this just becomes a 3, this just becomes a negative 5, this just becomes a negative 7, and that just becomes a negative 1. And my x minus 3 is replaced with just a 3. And now if you memorize this following process, you'll get the same result as we did before. We drop down the first coefficient. Now we multiply these, we write it there. We add downward. -5 plus 9 is 4. Repeat. We multiply these, we write that there. We add downward. -7 plus 12 is 5. And one more time, we multiply these. We write it under there. And adding, we get 14. Now look at the numbers we got below. 3, 4, 5. 3, 4, 5. We found the coefficients of the answer. Now we have to figure out what kind of a polynomial we had. If we start with the cubic and divide it by a linear, the degree will go down 1. That means the answer is a quadratic. So we take these coefficients and write it into what it actually is, 3x squared plus 4x plus 5 with a remainder of 14, just as before. The ultimate goal is to factor polynomials of degree 3, 4, 5, etc. You already know how to factor degree 2. Before we get there, we need some theorems. The remainder theorem says that when you take some polynomial, let's call it f of x, and divide it by some linear binomial, let's call it x minus a, the remainder is simply f evaluated at a. Let's see an example so you get what's going on. So find the remainder when this cubic polynomial, x squared plus x squared minus 6x plus 1, is divided by x minus 1. Of course, we could do long or synthetic division, but it's much faster to use the remainder theorem. The 0 associated with this factor is 1. 1 is the value that makes that 0. So rather than doing division, we simply plug 1 into that cubic polynomial. Doing that, the output value is -3, and it's that simple. The remainder is -3. An extension of the remainder theorem is called the factor theorem. Let's say we did that process as before, and we found that the remainder was 0. Well, the definition of a factor is something that leaves a remainder of 0 when divided into the dividend. So the factor theorem states that x minus a is a factor of some polynomial if, when you evaluate the function at a, you get 0. So the question, is x minus 2 a factor of x cubed plus 2x squared minus 4x minus 8? We're not going to go ahead and do long or synthetic division, much faster to simply take the 0 that goes with this binomial factor and plug it in. So 2 is what makes this 0, and that's what we're plugging in here into x. If you do that and simplify, we get 0, and by the factor theorem, x minus 2 is a factor of this polynomial. The very last bit of information we need before we factor polynomials is how to tell whether a number could potentially be a 0 of a polynomial. So here I have this cubic, and the constant term at the end is 24. The only possible zeros for this cubic are all the factors of 24, negative and positive. So 1, 2, 3, 4, 6, 8, 12, and 24. 24 has a lot of factors. These are all potential values that can make this polynomial equal to 0. That means 5 can never be a 0 of this, 7 can't, 11 can't. Only these values could possibly give you a 0. Things get a bit more complicated when you have a coefficient in front. Once again, we look at the factors of the last constant term. Here it's 15. The factors of 15 are 1, 3, 5, and 15, positive or negative. And we also look at the factors of the first term, the leading coefficient. 4 has factors 1 and 2 and 4. So all of the possible zeros of this polynomial are the factors of the constant divided by the factors of the leading coefficient. That means this polynomial may very well have a 0 or x-intercept at 15 over 4 or 3 over 2 or -5 over 4. But it may also simply have a 0 at 3 over 1, which is 3, or 5 over 1, or 15 over 1. So you may get fraction zeros, or you may get whole number zeros. It's hard to tell when you have it in standard form. Next, we want to look at the possible zeros of this polynomial. You use the constant at the end and look at all of its factors. 48 has a lot. I stopped because hopefully it's one of these numbers. Next, we're going to use the factor theorem. Remember, that says something is a 0 or a factor if you plug it in and out comes 0. First, I tried x equals to 1. When you substitute 1 into here, out comes -35. So by the factor theorem, This is not a factor. 1 is not a 0. I move on. Next, let's try positive 2. When I plug 2 into that function, success, I get 0. That means that x minus 2 is a factor and 2 is a 0. So now that we've established that 2 is a 0 and therefore x minus 2 is a factor, we can do long or synthetic division to find some other factor. I did synthetic. Here are the coefficients of that polynomial, and here's the 0, 2. And remember, in synthetic division, we drop down the first, multiply, add, multiply, add, multiply, add. This is a good check. My remainder is 0, so that's good. I did find a factor after all. This answer that we get at the bottom, remember, is these are the coefficients of the answer. I started with a cubic. I divided by a linear. This is quadratic. So here's the factor I pulled out, x. Here's the factor I found using the remainder theorem, or the factor theorem. I found that 2 was a 0, and therefore x minus 2 is a factor. Here's the factor I found through division. Now we just factor this quadratic as we normally do. What multiplies to this and adds to this? 24, 10, 4 and 6. 4 times 6 is 24. 4 plus 6 is 10. And there we have it. We have broken down that big quartic into 4 linear factors. And if we wanted to, we could now state the zeros. 0, 2, -4, and -6. There are 2 special cases of factoring that we're going to see. Sum of cubes and difference of cubes. In a sum of cubes, we are adding 2 cubes together. The quickest and easiest way to do this is to remember this formula. A sum of cubes breaks down into the base of the first plus the base of the second, and then the first squared minus the 2 multiplied plus the second squared. So an example, I know that this is a sum of cubes because 27 is a cube, x cubed, 64 is 4 cubed, and there's y cubed. In this instance, my a is 3x and my b is 4y. And now slotting these things into that formula, we have a plus b becomes 3x plus 4y, a squared minus a times b, plus b squared. Simplifying, we're left with this. This trinomial is not factorable. You can try for yourself. We're done. There's also what's called a difference of cubes, essentially the same. Where we had a plus, we now have a minus. Where we had a plus here, we now have a minus. And where we had a minus here, we now have a plus. For example, 125x cubed minus 8. This number is 5 cubed, x cubed. This number is 2 cubed. So here my a is 5x. This is equal to 5x cubed. And my b is 2 because this is 2 cubed. Once again, slotting each of the things into this formula and simplifying this trinomial, we end up with that. Now that we know how to factor polynomials of degree 3 or greater, we can solve polynomial equations of degree 3 or greater. So here I've got an equation that's degree 3. First step of solving polynomials is, of course, get all the terms on one side and set the other side to 0. We already know that from quadratics. Now we're going to factor this left-hand side. So we look for the possible zeros, factors of the last term, divided by factors of the first term's coefficient. That means could be plus or minus 1, plus or minus 3, plus or minus 1/2, or plus or minus 3 over 2. Let's hope it's a whole number. I tried positive 1 and found that when I plugged 1 back in, I got -4, so 1 is not a 0 and x minus 1 is not a factor. I had more success with -1. When I plugged -1 into that function, I got 0, which means -1 is a 0, and therefore x plus 1 is a factor. But of course, we are not done. We just found one factor. There are a couple more. So we're going to do long or synthetic division to find the other quadratic that goes with this, such that that quadratic times this linear binomial gives you that cubic. I did synthetic division. My coefficients, 2, -5, -4, +3. Drop it down, multiply, add, multiply, add, multiply, add. Remainder 0 should be. Now I'm here. There's the factor I found using the factor theorem. There's the factor I found doing synthetic division. Now all that's left to do is break this quadratic down into its factors. We can do that by multiplies to 6, adds to -7, and continuing the way that we already know. Once it's fully factored, all we have to do is set each of the factors to 0 and solve for x. The 0 here is -1, because -1 plus 1 is 0. The 0 here is 3, because 3 minus 3 is 0. This one's a bit trickier to do in your head. If you have a hard time with these, go off and solve it in the margin. Ask yourself, when does 2x minus 1 equal to 0? And by isolating for x, we find that the answer is 1/2. 2 times 1/2 minus 1 is also 0. This has 3 roots, or 3 zeros, or 3 x-intercepts, all equivalent terms. So let's try a word problem where we end up with a polynomial to solve that is degree 3. So say you want to construct a box such that its height is 3 centimeters greater than its width, and its length is 5 centimeters greater than its width, and you want the box to have a volume of 400 centimeters cubed. So I've sketched this right here. Here's my width, I've called that x. I want my height to be 3 centimeters greater, and I want my length to be 5 centimeters greater. So the expressions that give my width are x, height, x plus 3, and length, x plus 5. Remember that the volume of a box or a rectangular prism is given by length times width times height. I know all these things. I have an expression for length, an expression for width, an expression for height, and I set that equal to 400 because I want it to equal 400. Next, we just have to distribute this all out, get it in standard form on one side of the equal sign, and 0 on the other. So multiplying these binomials, I got this. Distributing in that x, I got this. And lastly, bring the 400 over so that all the terms are on one side and equal to 0. And away we go. Next, we have to solve this. Factor theorem. 400 has a lot of factors. Let's hope we find a relatively small one. There's no use trying negative numbers. We know the answer that we're looking for is not negative. We don't want a negative width. I happen to know the answer, so I tried 5. 5 works, and we get 0 when we plug 5 in. But we're not done yet. 5 works, but there may very well be another answer, so we have to keep going and find the other factors. Once again, long or synthetic division will give you the other quadratic factor. Bring it down, multiply, add, multiply, add, multiply, oops, multiply, add, remainder 0, we're good. And we're here. This is the one I found through trial and error, the factor theorem, and this is the one I found through synthetic division. Now this is not factorable. I cannot find two numbers which multiply to 80 and add to 13. So we have our backup plan, the quadratic formula. But remember this, the discriminant of the quadratic formula tells you whether there are solutions or not solutions. This is b squared minus 4ac. Remember, the coefficients on a quadratic equation will tell you whether there is a solution or not. And plugging that in, I find that it's negative 151. When the discriminant is negative, there is no solution, which means the only answer to this problem is x equals to 5. And don't forget to go back and find my width, my height, my length. If width is 5, height is 8, and length is 10. Solving rational equations. Remember, the nice thing about equations is as long as you do the same thing to each and every term, to both sides of the equal sign, the equation stays balanced. So because nobody seems to like working with fractions, we can just get rid of them when we have fractions in an equation. So if you notice, the denominator here is 2, 4, 4. The lowest common denominator of those numbers is, of course, 4. Multiplying each of these terms by 4 down here results in 4x over 2 minus 12x over 4 and 28 over 4. Now each of these, if you simplify, simply becomes 2x and a 3x and a 7, and just like that, fractions are gone, much easier to solve. Now I just collect my like terms, and finally we get x equals negative 7. This one's a bit trickier because our variable is in the denominator. So if I look at each of the denominators, x, x plus 1, and technically that's 2 over 1, the lowest common denominator is simply multiplying these two together. It's the best I can do. So we're going to take this entire equation and multiply everything by x and by x plus 1. The result is on this next line. This first thing is going to become 3 times x plus 1, still over x. The second one becomes 4 times x plus 1, still over x plus 1. And don't forget the 2 also gets multiplied by x and by x plus 1. Now, there are common factors in the numerator and the denominator. Here the x's cancel out. Here the x plus 1 cancel out. Fractions are gone. Now that the fractions are gone, we treat this like any other equation. We want to distribute on this side, collect the like terms. This is quadratic, so we want all the terms on one side equal to 0. And now I factored, multiply to -6, add to -5, -6 and 1, and so on. Here it is in factored form, and I get 2 solutions, x equals 3 and x equals to -1/2.